In this videotape, we are going to revisit multiplication and division of algebraic fractions. This time, however, the problems are going to be a little bit more complicated, and we're going to need our techniques of factoring. Okay. Before we get into that, let me just remind you of the rule for multiplication of fractions. Rule for multiplying fractions. If you have A over B times C over D, we're assuming, of course, B and D are not 0. To multiply two fractions, you multiply their tops, you multiply their numerators, and divide by the product of the denominators. So it's AC over BD. Now, in a numerical example, let's say you have 4/9 times 18/2. Okay, you can multiply the tops and divide by the product of the bottoms. 4 times 18 gives you 72. 9 times 2, 18. And now that's not in lowest terms. We would always like to get our fractions in lowest terms. That is, there should be no factors in common to the numerator and denominator. So let's see. We see that 2 goes into 18 9 times. 2 goes into 72 36 times. So apparently we could have done better than 2. 9 goes into 9 once, into 36 4 times, for a final answer of 4 over 1, or just 4. Okay, now it's a lot easier in multiplying fractions if you try to cancel out factors that are in common before you perform the multiplication. In other words, in this particular problem, we could have said, well, 2 goes into 2 once, into 4 twice, 9 goes into 9 once, into 18 twice, and now we multiply 2 over 1 times 2 over 1, we get 4 over 1, or just 4. So whenever possible, try to simplify, cancel factors out in common before you do the multiplication. Okay, let's try some algebraic examples. Remember, we do want to get our fractions into lowest terms. 9x cubed y squared over 4w squared z times 8w z squared over 3xy squared. Okay, now we could multiply the tops and divide by the product of the bottoms, but we first can, it's a lot easier if we simplify things first. Well, let's see. 4 goes into 4 once, into 8 twice. 3 goes into 3 once, into 9 3 times. In other words, we divided numerator and denominator by 3. Remember, canceling out is a form of division. Okay, when we cancel out, say, or when we cancel out a factor, we're dividing numerator and denominator by that factor, which means it has to be a factor. Everything has to be joined by multiplication before you start. In this particular problem, everything is. Okay, we'll see other examples later on that will cause more difficulty. Okay, let's see. X. We have an x cubed on the top and an x on the bottom. We can divide top and bottom by x. We divide the bottom by x, we get 1. The x cubed by x, we get x squared. Okay, we can divide numerator and denominator by y squared. Okay, in both cases leaving you with 1. W. We can divide numerator and denominator by w. W divided by w is 1. W into w squared. Okay, goes w times. We divided w squared by w. We're left with the w here. Divide numerator and denominator by z. Z divided by z. 1. Z squared divided by z leaves you with z. Okay, we've removed all the common factors. Now to do the multiplication, we have 3x squared times 2z on top, or 6x squared z on the top. On the bottom, all that remains is w times 1, or just w. And here we have the answer. Okay, now this was still, relatively speaking, a fairly simple example in that everything was joined by multiplication. Okay, the factors were completely obvious. Now let's consider a slightly more complicated problem. Say we have x plus 4 divided by x squared minus 4x. Okay, that fraction times 2x minus 8. Okay, really 2x minus 8 is 2x minus 8 over 1. So it's like multiplication of two fractions. Okay, The only catch here is that before we can start canceling out, we have to have factors. Okay, for example, x, you can't cancel these x's out, you can't cancel these 4's out, because x is not a factor in the numerator. Okay, it's a term here, x plus 4, but they're not joined by multiplication. If it was 4 times x, then x would be a factor and 4 would be a factor. Okay, but with x plus 4, neither x nor 4 is a factor. Okay, so what we have to do before we can remember, our aim is to multiply and get the answers into lowest terms. Okay, when we have a complicated problem like this, the idea is to factor completely all the numerators and all the denominators, and then look for factors that the numerator and denominators have in common. And of course, we will cancel out those factors. Well, x plus 4, that's as far as we're going to go with that. X squared minus 4x, we notice that the x squared and the minus 4x have a factor in common, namely x. We can pull out an x, leaving us with x times x minus 4. X squared minus 4x is x times x minus 4. Multiplying, we get x squared minus 4x. Now, 2x minus 8, these two terms have a factor in common. They have 2 in common. We can pull out a 2, and that'll leave us with 2 times x minus 4, giving us, when you multiply, of course, the 2x minus 8 that we wanted. Now that everything is factored, in other words, it's x plus 4 times 2 times x minus 4, x times x minus 4 in the bottom, we can look for factors that we can cancel out. Okay, remember, whether or not, if it's completely factored, whether or not the parentheses are there, this is really like x plus 4 times 2 in parentheses times x minus 4. We have all these things joined by multiplication. Within parentheses, in other words, this factor, for example, is x plus 4. The plus sign is okay inside the parentheses. The whole factor, though, is x plus 4. All the factors have to be joined by multiplication. Now, x minus 4 can be canceled out, top and bottom, giving us a final answer. That's about as far as we can go here. 2 times x plus 4 over x. You could make it 2x plus 8 over x. It can't be reduced any further. You cannot cancel out the x's here because x is not a factor in the numerator. The numerator has 2 and x plus 4. Those are the factors. You cannot just pick out the x and cancel it. Okay, let's try another example. We want to multiply x squared minus 4x minus 5 over x squared minus 1 times 5x minus 5 over x squared minus 10x plus 25. We're going to factor numerator and denominator, each of the numerators and denominators completely, and we're then going to look for factors in common that we can cancel out. If you'd like to try this problem on your own, you can shut off the videotape machine and come back to me to check your answer. Okay, now, x squared minus 4x minus 5. First thing we notice is that there's nothing in common that we can pull out. Here, we'll have to try to factor this in this fashion. We want two numbers which multiply to minus 5 and add to minus 4, so we can use minus 5 and plus 1, giving us x. Checking this by FOIL, we have x squared plus 1x minus 5x. That gives you the minus 4x minus 5. First terms, outer terms, inner terms, last terms. Okay, x squared minus 1 is easy to factor because that's the difference of two squares. We can make that x plus 1 times x minus 1. Okay, 5x minus 5. We notice in this particular polynomial we have 5 in common. These two terms have 5 in common. We can pull out a 5, leaving us with 5 times x minus 1 in parentheses. And on the bottom here, there is nothing in common that we can pull out, but we can factor, okay, two numbers which multiply to plus 25 and add to minus 10. And of course, they're minus 5 and minus 5, giving us, once again, checking by FOIL, x squared minus 5x for minus 10x, and then plus 25. Okay, now that everything is factored, we look for factors in common, numerator and denominator, that we can cancel out. We see we can divide numerator and denominator by x plus 1, cancel the x plus 1s. We can cancel the x minus 1s. We can cancel one of the x minus 5s in the bottom with the x minus 5 in the top. Okay, leaving us with 5 over x minus 5 as our answer, and that's as far as you go. You cannot cancel the 5 since 5 is not a factor in the denominator. Okay, this is x minus 5, not x times 5. Okay, now we can also use these ideas for division of fractions. After all, division is a kind of multiplication. The rule for dividing fractions, just reminding you, if you have a over b divided by c over d, it can be written this way or this way, a over b divided by c over d. Okay, this means the same thing. A over b divided by c over d. Very often you'll see it written this way just to save space, but it means the same thing. A over b divided by c over d. To work this out, you invert the divisor here. What you're dividing, in other words, you're dividing a over b by c over d. You invert the divisor, c over d, and then multiply, giving you AD over BC. So to divide two fractions, you invert the divisor and multiply. In this problem, you invert the second fraction here and multiply. And remember, this is another way of writing this. Okay, let's try some examples of this. After you've done your step when you invert, of course, it just reduces to a multiplication problem. X squared y plus xy squared over x squared minus y squared. This is to be divided by xy. Okay, if you don't feel that looks like a fraction, of course, you can make this xy over 1. Now it looks a little bit more like a fraction. Okay? To do this, we're going to invert and multiply x squared y plus xy squared over x squared minus y squared times 1 over xy. And now we will try to factor completely the numerators and the denominators. Okay, now we look at the first numerator here, x squared y plus xy squared, and we see that these two terms have xy in common. If you factor out the xy, you are left with x plus y. When you multiply through, you get x squared y plus xy squared, which is, of course, what you had there. X squared minus y squared, the difference of two squares here, factors into x plus y times x minus y. This times 1 over xy. Now, in fact, xy is a factor in the numerator and the denominator. We can cancel the xy's. X plus y is a factor in the numerator and the denominator, leaving us with a final answer of 1 over x minus y. Okay, and for our last example, let's try this. 4x squared minus 16x over x squared divided by the fraction x squared minus 6x plus 8 all over 2x. Okay, first step would be to invert and multiply. So we'll make this 4x squared minus 16x over x squared times, we invert and multiply, 2x for x squared minus 6x plus 8. Now we try to factor completely the numerators and the denominators. The first thing we come to is 4x squared minus 16x, and we see that these two terms have 4x in common. If we pull out a 4x, we'd be left with x minus 4 here. Multiplying, we get 4x squared minus 16x, which is what we want. The bottom, x squared, of course, is just x times x. You can leave it x squared or make it x times x. 2x, x squared minus 6x plus 8. There is nothing in common that we can pull out. We'll factor by this method instead. We want two numbers which multiply to plus 8 and add to minus 6, and those would be x minus 4, x minus 2. Minus 4 and minus 2 do it for you. You get x squared minus 2x minus 4x with a minus 6x plus 8. Okay, now it's completely factored, and we're going to try to simplify. Let's see, we can cancel out the x minus 4 on the top and the bottom. Okay, we can cancel this x with this x. We can cancel this x with this x. Okay, that's about as far as we can go, giving us now on the top, the only thing that remains is the 4 times 2, which is 8. And on the bottom, these are all 1s, x minus 2. Okay, and that's as far as you can go. You cannot cancel the 2 into the 8, since 2 is not a factor in the denominator. And that brings us to the end of the tape.